All right, and welcome back. So today we are going to be talking about how to graph quadratic functions. This is going to be section 8.3 that are in your guided notes. This is going to be stemming from what we've previously learned, and we're really going to use this idea of the vertex, the zeros, and the axis of symmetry in helping us graph these quadratic functions. So without further ado, let's talk about how we do it. So we can use the axis of symmetry, the vertex, and the y-intercept to help us graph a quadratic function. So we are given this quadratic function, y equals x squared plus 6x plus 8, and we're asked to graph it. So let's go through the step-by-step process that we are going to take to help us graph this quadratic function. Well, the first thing we're going to do is we're going to find that axis of symmetry. We know that we have the formula for the axis of symmetry is x is equal to the opposite of b divided by 2a. So we're going to identify our a, b, and c values within our quadratic function. Let's just list out again ax squared plus bx plus c. So for this function, we have to identify our a and our b values. Well, our b value is 6, our a value is 1. So we're going to substitute in our a and our b. It's going to be the opposite of 6 divided by 2 times 1. Well, 6 divided by 2 is 3, and the opposite is going to be negative 3. Therefore, we're going to have our axis of symmetry as the vertical line x is equal to negative 3. So we're going to draw that vertical line going straight up and down through the x value of negative 3. After we do that, we're going to find the vertex. We know that our vertex is going to lie on the axis of symmetry, and we know the x value is already negative 3. So what we're going to do is we're going to substitute in our x value of negative 3 into our quadratic equation. When we do that, we find that y is equal to negative 1. So we can now graph the vertex negative 3, negative 1. Step 3 is we're going to identify the y-intercept. Just like a linear function, we're going to have a y-intercept. The y-intercept is going to be the number all by itself. It's our c value, because we know to be a y-intercept is when x is equal to 0. So if we were to substitute in 0 for x, we'd find that y is equal to 8. Therefore, our y-intercept is 8, or 0, 8. So now in the bottom left of your screen is going to look like what we should have so far. We have our axis of symmetry going through x is equal to negative 3. We have our vertex of negative 3, negative 1. And we have our y-intercept of 0, 8. Now we're going to choose two x values that are on the same side of the axis of symmetry as the point containing the y-intercept. Notice how our y-intercept is over on the right-hand side of that axis of symmetry. So we're going to choose two values that are to the right of our axis of symmetry. 0 is already used, so we can't use 0. But we can definitely use negative 2 and negative 1. So we're going to substitute in the x values of negative 2, find our y, which happens to be 0. So we can then graph negative 2, 0. Then we're going to substitute in negative 1. And you can, again, choose any points that you want, but we're just going to choose negative 2 and negative 1. And we find that the corresponding y value is 3. So we can graph negative 1, 3. Here's a little Q-tip for you. Wherever your vertex is, we want to go 1 unit and then 1 more unit. Quadratics are going to get very big very quickly. So if we can identify some x values that are very close to our axis of symmetry, then we're going to be in a much better position to find those y values and use them to graph it. Don't start getting big with your x values and further away from your axis of symmetry. Stay as close to your axis of symmetry as you can. That's why we use negative 2 and negative 1, because negative 2 is 1 unit away from our axis of symmetry. Negative 1 is 2 units away from our axis of symmetry. So if we're able to stay with that pattern, it's going to take less time for us to graph, and it's going to be a lot easier for us to visualize what is occurring. Now we can graph everything on our line. and we're going to reflect those points and connect them with a smooth curve. So again, you're going to notice now that when we had x was -2, that's 1 unit away on the right-hand side of our axis of symmetry. So now, since it's symmetrical, we plot a point 1 unit left of our axis of symmetry. I'm going to go in blue now. When x was equal to -1, that's 2 units to the right of our axis of symmetry. So we're going to go 2 units to the left of our axis of symmetry, because to be symmetrical means to be the same thing on either side. And that's how we graph a quadratic function. Great. With that, please work on problem numbers 1 through 5 on the guided notes and resume when you're ready to go on. All right, so there are many real-life situations that involve these quadratic functions. It is important to interpret the graphs correctly. Let's say we have this situation. The height in feet of a soccer ball kicked in the air can be modeled by the given function, f of t is equal to -16t squared plus 32t. We want to find the ball's maximum height and the time it takes the ball to reach this height. Then we're going to find how long the ball is in the air. We're also given that the graph shows the appropriate height of the soccer ball after t seconds, and the x-axis is time t in seconds, the y-axis is height h in feet. So looking at our graph here, we're going to be able to identify a couple of things. We're going to see that the vertex is the maximum height. The vertex is the maximum height. That's going to be 16 feet after 1 second. And we can determine that because we know that x is our seconds and y is our height. So we find that we have y of 16 and x of 1. So that means after 1 second, the ball is 16 feet in the air. We're also going to see that the height at 0 seconds is 0 feet, because if we're looking at this graph and we're interpreting it, well, we go through the point 0, 0, which is x is our time, y is our height. So after 0 seconds is going to be 0 feet in the air. Also, we're going to see that the height after 2 seconds is 0 feet, because we again are having that point on the x-axis, which means that y is 0. So if y is 0, that means the ball is not in the air. We don't have any feet from the ground. We don't have any height. So after 0 seconds and after 2 seconds, the ball is going to be on the ground. And we're going to be able to determine that 2 seconds is the length of the time that the ball is in the air. Again, because the ball is on the ground after 0 seconds and the ball is on the ground after 2 seconds. So that difference there is going to be our answer to determine how long the ball is in the air. Because we can't be in the air for 3 seconds, well, because we're on the ground at 0 and we're on the ground at 2. So the difference there is going to be helping us determine the length that the time ball is in the air. Awesome. With this, the maximum height again is 16 feet and it takes 1 second to reach this height. And again, we already shared this, but the soccer ball is in the air for 2 seconds. Fantastic job with this, kiddos. You're working super duper hard. Keep up the great work. Keep making yourself proud. Please work on problems 6 through 8 on the guided notes. Let me know if you have any questions, and I'll talk to you soon.